So this problem says three 70 kg deer are standing on a flat 200 kg rock. 70 kg is roughly, our masses are roughly 70 kgs. So what's that? On a flat 200 kg rock, that is on an ice-covered pond. So they're essentially saying frictionless surface. A gunshot goes off and the deer scatter. And that's with deer A running at 15 meters per second I plus 5J, B running at minus 12I, 8J, and C running at 1.2I minus 18J. What is the velocity of the rock on which they were standing? Okay, so here's a top view of the objects. And initial momentum is 0. And then, so there's the rock. One deer goes off like that. B and C goes at in that direction. And let's say the rock goes off in this direction. Okay, the initial momentum is 0, so the final momentum should be 0. Okay. All right, VA is, I'm just going to write these velocities here, 15I plus 5J, and everything is in SI units. VB is minus 12I plus 8J. VC is 1.2I minus 18J. Okay. And the velocity of the rock is what we're trying to find. What is the velocity of the rock on which they were standing? Okay, so let's look at the x components. Zero is equal to, and the masses of all the deers are equal. So, well, mass A V AX plus mass B VBX plus mass C VCX plus mass rock VRX. Okay, so everybody understand the subscripts? What do you not understand? This is the x component of the velocity, initial x component of the momentum. That should equal the final x component of the momentum. In the final configuration, you got 4 things moving. This guy, this guy, this guy, and this guy. That is mass of deer A, x component of deer A velocity. Everybody understand? All right. So 0 is equal to 70 kgs, and the masses of all deers are common, so we'll write down the x component of the velocities. It's just this, 15 minus 12 plus 1.2. Plus the rock is 200 kgs times VRX. No? All right, now we'll look at the y component of the motion. Again, 0 is equal to and the y component of the velocities are 5, 8, and minus 18. Okay, so VRY is, so that's minus 10 minus 5, 70 times 5 divided by 200. And that's 5 goes, that's 40, and that's 1.75. 70 divided by 40 is 1.75. All right, so the velocity of the rock is minus 1.47 I plus 1.75 J. Okay, so that's the recoil velocity of the rock. Yep. Okay. Again, all the principle we've been using is in collisions and explosions, momentum is conserved. Okay. And we've been dealing with two-dimensional momentum in the past two problems. What problem number is this?